Coming to you from New York City, here's an explanation about number 43 in section 7.8. Firstly, it matches none of our known formulas. Secondly, it does match our Pythagorean idea, c squared minus adjacent side squared in a right triangle. So let's draw that. So with the Pythagorean theorem, if we solve for one of the sides, it'll be the square root of the hypotenuse squared minus the other leg squared, which matches our denominator. So that's how we're going to build our trig substitution in this problem. The question would be, do we let the side that's being squared here, giving us 9, that is a side of 3, be this leg or this leg? Remember, we're introducing a new variable for our trig substitution. It can be anything. I'm going to choose y. And if we let the 3 be this leg, then which trig ratio uses these two sides? Sine ratio. Sine is equal to 3 over x. But let's make a choice so that x isn't in the denominator. We could do cosecant. So that cosecant of y is the hypotenuse over the opposite. That has x in the numerator, but it's using a cofunction, and I like to stay away from the cofunctions. Not a great reason. I just like to keep it simple and always do a non-cofunction, which means we're going to take the 3 and put it over here, because now the trig ratio that's not a cofunction and that keeps x in the numerator is secant. So secant of y is equal to x over 3. Now, things are going to start to fall into place very nicely for this trig substitution. Let's find the missing side using the Pythagorean theorem. That will be the square root of x squared minus 9, which is exactly our denominator. All right, so we can use trigonometry to make a substitution in terms of y for the denominator, and we're also going to need a substitution for dx, which means we're going to need to take the derivative of this nice, simple trig function. Let's begin by making a substitution for the denominator. What trig ratio uses something simple, like x squared minus 9 rooted? And not that one, but this one. That would be the tangent ratio. So tangent of y is this root over 3. Let's write that down. So tangent of y is the opposite side divided by the adjacent side. And so this denominator equals 3 times tangent of y. And now we can make that substitution. But we're still left with this dx. And so to complete our substitution, we need to obtain what a dx is by using this equation and taking the derivative. Solving this for dx, we have dx equals 3 secant y tangent y dy. And now we can make our substitution in there. And you can see that things are ending up very nicely here. 3's will cancel out. Tangent y cancels out. And all we're left with is the antiderivative of secant of y dy. This is the formula that we know. It's the natural log of the absolute value of secant of y plus tangent of y. Plus c, but we're actually doing a definite integral from 3 to 5. So let's go ahead and put things back in terms of x by using our triangle. Secant of y is hypotenuse over adjacent, or x over 3. And tangent of y is the root over 3, or opposite over adjacent. And from 3 to 5. So this expression when x is 5 minus this expression when x is 3. So we have the natural log of 9/3 minus the natural log of 1, or just the natural log of 3.